Hi everyone. In this talk, you will learn about Media3, media editing on Android. My name is Kristina, and I'm an engineering manager at Android media editing team at Google. Today, you will have the overview over Media3, so we are all on the same page. And then we'll dive into Transformer APIs and see a bunch of examples of how to use them. So what is Jetpack Media3 library? Jetpack Media3 is a one-stop shop for APIs about media playback and editing use cases. Version 1.0 of Media3 released earlier last year, and we've already seen that 30% of top 1,000 apps in Play Store have dependency on Media3. I imagine many of you already know or use ExoPlayer. Can I see show of hands who heard of ExoPlayer? Using? Okay, thanks. So quite a familiar crowd. Yes, and today, however, we're going to talk about a newer addition to Media3 is the Transformer module, which is focusing on media editing use cases. Let's dive into Media3 Transformer APIs. Despite the growing importance of social media and video, app developers struggle to create media editing features that perform consistently well across fragmented Android landscape. To address this, we are investing in support libraries that offer improved quality and new capabilities of media editing to empower you to build cool experiences for your users. Our team is working on Transformer API to enable Android developers like yourself to build editing features easily. Transformer covers media editing use cases, such as converting from one media file format to another or downscaling. Transformer can also be used to change the structure of the media. For example, you can trim a media file, or you can combine several media files together. And lastly, you can use Transformer for video processing and audio processing, for example, applying video effects. We are focused on three main goals with Transformer. First, it should be easy. We want to enable you to be more efficient as you write and maintain code. For comparison, without Media3, you will need about 300 lines of code to build a grayscale effect. With Media3, you will only need to write about 30 lines of code. Moving on. Transformer is built with performance and quality in mind, including device-specific optimizations. And of course, we also want Transformer to be reliable. Transformer supports API levels 21 onwards, so you can reach 99% of active devices. So let's start with the basics, and I show you how Transformer is built. Here's a simple basic usage of Transformer APIs. We start with media item and pass it to edited media item when we build it. Then we create a Transformer instance and add a listener so it can notify us when the transformation is complete or when there are any error cases. And finally, we start the transformation by supplying it with edited media item we just defined and output path. Here's an illustration of Transformer media editing pipeline. Each of the steps are also annotated with the name of the module in Media3 that is used or framework API associated with it. For example, for demaxing, we need to use Media3 extractor or Media3 ExoPlayer APIs. And for maxing, we offer two options. You can use Media3 Maxer or a framework Media Maxer. Transformer is highly customizable, and we achieve it by building factory-based APIs. This approach allows you to create custom components if needed. The factory-based APIs is here to help to easily recreate and reconfigure components when needed. Next, we'll speak about how Transformer makes decisions, whether and how to process input data. So let's get back to the pipeline that we talked about. For some operations, not all processing steps are required. So for example, we can rotate MP4 files, and in this, for example, we want to rotate it by 90 degrees. This we can achieve by just simply tweaking metadata. So let's see how this will look in Transformer. The only two pipeline stages required to do so is demaxing and maxing. Decode processing and encode can be skipped. And we call it transmaxing. This is great. So the export is done much faster because we're skipping several steps. And also it's good for quality of the video, because video encoding is lossy. And in this case, we're skipping this step. Here's the review and overview when Transformer transcodes versus transmaxes. And compared to FFmpeg, where transmaxing is something you need to define, and it's not a default setting. Although in Transformer, we always try to transmax. In this section, I will illustrate how we test and roll out Transformer changes to ensure broad device support. Transformer is regularly tested on a large set of devices. As you can see, it's about 170 and more devices, and it also includes Wear and TV devices. And we make sure that Transformer-generated files are able to play. Okay, let's dive into some actual examples on how to use Transformer. Starting off simple, I will show you how to transform from one file form to another. I showed you this code before as the basic use case. And moving on here to defining a MIME type that you want to get as your export, you're just defining it when you are instantiating Transformer, as demonstrated here. With Transformer, you can also trim media items. We can achieve it by using clipping configuration when we are creating our media item. We can define start and end position, and as demonstrated on the slide. In one of the latest Media3 releases, we introduced trim optimization. To reduce the latency of trimming of the beginning of the video, try enabling trim optimization. This speeds up transcoding, and we only then transcode a small part of the video and then put it together with the rest of the video. And that speeds up the transcoding significantly. Moving on, one of the features I want to highlight that is available in Transformer is image encoding. With Transformer, you can create videos out of images, as illustrated on this side, and also apply effects to it. In this sample, we are creating an edited media item using image URI, as you see here. We also need to define the duration of the video. In this example is 3 seconds. And set fixed frame rate, which is 30 in this example, but it depends on your use case. And next, we'll learn more about effects. And Media3 includes a host of video effects that you can use directly out of the box. The built-in Media3 effects are suitable for fundamental rendering tasks. With these effects, you can solve common problems that arise when you display content on the screen or when you encode a video. We provide efficient implementations for video scaling, tone mapping, and more. Let's look at some examples. For the first example, let's define a video effect that will flip a video horizontally and rotate 180 degrees. We will use scale and rotate transformation matrix effect and provide it and define it like this. Later, we add, in this example, we don't have any audio processors, so we just pass an empty list. And we then pass the list of all the effects we want to apply to this media item. Finally, we configure an edited media item using our input media item and the effects we want to apply to it. Here is what we end up, the final version. Let's see how we can use our effect module to create text and bitmap overlays. So let's see how you can add a text over your video. That's some of you, or it can be also the overlay of your company logo and so on. So it's a very common use case. So since text overlay is one of the effects provided by Media3, it's very simple. First, the overlay will be built with spannable string. So we give you the power to define the text, the style, everything you need. And now we add an overlay effect to a list of the video effects as we did before. And that should be it. Talking about overlays, we it's literally just added more examples how to animate overlays, as it was a highly requested feature. And check out our Transformer demo app. It can be still probably in main branch, but yes, check it out if you want to create some animated effects. But what if you want to do something fancier than we have in Media3 effects module? Here, we can create a custom effect by subclassing an inbuilt matrix transformation to zoom in for the first second of the video. The rest of the code remains the same. For advanced custom effects, you can implement a custom base GL shader program. The key method to take note here is a draw frame. In this method, you can process each frame, each individual frame. We actually use this to define some of the effects in Transformer 2. So you can check out, for example, overlay shader program or a color LUT shader program to learn how to do so. For even more advanced effects, you might want to customize GL shader program. Key method to note here is QInputFrame. The main difference here is that when you're overriding GL shader program, you can combine multiple frames you can have multiple input frames as the input. And then we defined our video effect as GL effect and passing our custom shader program. The example you see on your right. The example you see on the right is the Transformer demo app, and this is the integration with MediaPipe and face detection APIs. So if you want to integrate MediaPipe, you will need to implement a custom GL shader program. If you want to integrate your video editing pipeline with TF-Lite or RT-Lite, which is called now, you can check out our new code in a platform samples repository, how to do so. And this is the sample of our new byte buffer GL effect. All right, so far, I've only talked about single media editing. So we're editing single item. But next, in the next examples, I will show you how we can combine several media items together. So the pattern so far is you have a media item, you define the effects, you wrap it in edited media item, and you run a transformation. To create a composition, first we need to group our edited media items into edited media items sequences. A composition is then composed of 1 or 2 edited media item sequences. The current version is restricted to maximum 2 edited media item sequences, where one of them is audio background track. Future updates to Transformer will extend these capabilities, and you will be able to add more sequences. So let's create, and let's look at the example, and create a composition with these two videos and a background audio track. So as we did before, we're defining edited media items. I have 2 with video and 1 for audio track. And then we create edited media item sequence. The first one with 2 videos, so they're going sequentially, and the background sequence is the audio sequence. I'm setting loop the background audio to true, so that the audio track, if it's shorter, it will be repeating, so it will last over the whole composition. And the result, I'm not sure if the music is on. So you can hear the music. Yes. So that's how we combined two items and did the background audio track. As an example of operation that applied to entire composition, let's take a look at how Transformer can help you to handle special formats. With more and more devices supporting HDR video capture by default, you might need a way to tone map HDR to SDR to support more devices. Here you can see that we set the HDR mode onto composition to tone map HDR to SDR using OpenGL. On API levels 33 and up, Transformer tries to retain HDR data. But if it's not possible, we'll fall back to HDR to SDR tone mapping when it's not. We also have an option to have tone mapping with media codec. As I mentioned before, Exoplayer and Transformer works hand in hand. And next, I'd like to show you how you can use the same effects you define in Exoplayer. And if you're familiar with Exoplayer, as we know you are here in the audience, the only difference is you put set video effects when you're initializing your Exoplayer instance. Note there are some limitations for this. For example, set video effects need to be called before calling prepare. And we'd love to hear from you. I'm here at office hours today and tomorrow, so if you have any questions about Exoplayer or Transformer or any media use case, please come and find me, and I have my colleague with me as well. So we will be here today and tomorrow. And before we end this talk, I also recommend checking our GitHub repository. Just a reminder, Media3 is the open source project, and if you have any questions, any feature requests, you can always file an issue there. We are very active there, active community, so we want to help you and support you. So check out our Transformer demo app and our new composition demo with our yet experimental APIs for previewing your editing operations. And we also have platform samples where we have TF-Lite demo, for example, and another composition demo. And there is a social light as well, where you can see a simple use case of Transformer. And that's all from my side. Thank you.